Guys, how exciting. We are moving on to the object-oriented bit in Python. So let's start this third chapter. Looks like we're going to learn about classes initially. Okay, so object-oriented programming. Learn the fundamentals of the most widely used programming paradigm today, object-oriented programming. You will model real-world problems within your programs and learn how to write code that is easy to understand and maintain. By the end of this course, you'll be writing production quality Python code. Sweet, looks like we have about 18 hours of learning and a couple challenges. This is going to be very important. Object-oriented programming is the core of programming. So let's dive in. Very excited to learn it in Python. Okay, so object-oriented programming, or OOP, for short, is a way of writing code that relies on the concepts of classes and objects. The main benefits of writing code in an object-oriented way is to structure your program into simple, reusable pieces. So classes are going to be building these things. Like a class, let's say if you have a class of a human, quote unquote, you now have the model of what a human is. So you might predefine, okay, humans have an age, they have a name, they have a height, things like this. So then we can always point to that human class if we need data on a human, or if you want data on like an animal, you can make a class for an animal. And same thing, like color of fur. That's all I could think of for animals. But so on and so forth. If we need to build something for like cars, like if you're building for maybe like a dealership or something, you could build classes for cars, and cars have like a make, a model, a year. Now the actual make and model of the year, the value of that thing, of those things will change, but the structure of that remains the same amongst cars. So that's the idea of classes or object-oriented programming. Okay, so in this course, we'll be adding code, or we'll be coding the pieces of a real-time strategy game called Age of Dragons. Players will control armies of people, elves, orcs, and dragons as they fly with one another online, or as they fight with one another online. Guys, forgive me, I just rolled out of bed here like 7:30 in the morning. Forgive me, so we're getting started, we're cruising right along. If you're familiar with the Age of Empires, Warcraft, Starcraft, or something like that, cool. So it's something like that. So your assignment is, your manager has noticed that there is a lot of repetitive code in the Age of Dragons in your code base. She asks you to what's the term in software? Let me actually pop this up real quick, which is dry programming, which means do not repeat yourself. Dry. So any code that's repetitive, typically there could be an alternative way to make it not repetitive. So let's keep reading. So there's repetitive code here. She's tasked you with reworking the fight soldiers function so that the damage per second calculation logic is only written once. Notice how these two lines are practically identical. There's probably, right here. Yep. So they're basically identical. We just need to figure out how to make this not like this. So we remove these lines from the fight soldiers function and replaced them with calls get soldier DPS. Finish the get soldier DPS damage per second function so that it uses the same logic as the lines above. Get soldier damage per second should take a soldier, which is a dictionary, and return it with its damage per a second. Okay, so let's read that one more time. So it should take a dictionary. So the soldier should be something like this, right? Should have this, and then within this, as I was kind of referencing with like a car make model, the soldier could have like a health, right? We could say like 100, but what they also want is DPS, so damage per second. Maybe it's like 10. This way, whenever we return a soldier, now I don't know if this is syntactically correct, but this way, whenever we return it, so we don't have to repeat the line here. We can actually just pass in the soldier dot DPS, and that would, or this, right? Soldier DPS. If we were passing in the soldier down here, this way we don't have to keep passing in. See how they're passing in soldier 1, and then we'd also have to pass in like soldier 2 and then soldier 3 because they're unique objects. So instead, what you can do is just pass in soldier, and boom, and you could do something like that potentially. But let's say I don't think that's the logic necessarily they want us to do. So let's kind of see what's going on. So we remove these lines from fight soldier function and replace them with calls to the soldier DPS. I see. So maybe we're not supposed to even touch these. Finish the get soldier DPS function so it uses the same logic as the lines above. Get soldier DPS should take a soldier, which is a dictionary, and return its DPS. Okay, so let's print the soldier and let's see what the soldier has in it. Perfect. So it does come back as a dictionary. So I'll say soldier just to see a little bit more granularly. This is the one that we're printing here. This is the dictionary we're receiving. So the damage and attacks per second. So I imagine we could just do damage per second. So damage divided by attacks per sec. So we could say soldier damage. Do you guys see how I'm getting that too with these? So this is our dictionary, and I'm just defining damage here. And let's see, we could do soldier and attacks per second. Okay, so let's see this now. Let's print this or run this. Boom. Okay, so that's what we are getting. And let's delete all this print statement stuff and just return this and see if that will work. We passed 2 of the tests, so we're chipping away at it. I really don't know what else we should be doing, so which is a dictionary. So it returns get soldier damage per second. Maybe it's times instead of, there we go. Okay, that would make sense. Amount of damages times per second. Okay, cool. So we got that down. Again, just looking at these soldiers, this is the trick here. So print statements, I always do stuff like this. Add a little star so I can see exactly, okay, this is what's being passed in, boom, boom. And now we can identify, that's our dictionary. And that dictionary is with all the data. So that helps us a ton. Okay, let's move forward. So clean code makes your program more efficient. It makes it more readable. Easier to work with as a developer is going to be the answer I'm going to go with here, but we can obviously read more. So object-oriented programming and other paradigms, functional programming, are all about making code easier to work with and understand. Clean code is more important than machine readable code, in my opinion, because a lot of the coding is humans interacting with the machine, right? So that's kind of what we're doing. The machine transpiles it to binary. We don't need to make binary code. Some engineers I've worked with do that, and it's just miserable. To be honest, it's like don't use ones and zeros for Boolean values. I know people can use ones and zeros for Boolean values, but just use true false, you know what I mean? Or just use some E numbers. But I don't know. I don't have all the answers either. I could probably brush up on some of my code. So any fool can write code that a computer can understand. Good programmers write code that humans can understand. I love it. That's what clean code is making sure that other people can read it. So it's not a way to make your program run faster. It could. It's not a way to make your program use less memory. It could. That's not the goal. So what it is designed to make code easier to work with in many situations. It's designed for other developers and other humans to read the code in the real world. It's a way to find bugs a lot quicker, develop new features quicker, and it's just the best way to stay sane as a software engineer. Love it. Love it. So the primary goal of object-oriented programming is to objectify people. Kind of, yeah. I mean, not just people, but it's actually objectifying data. So let's see. We'll send it. That sounds a bit aggressive. What is it? Write cleaner code? That would make sense. We're the cleaner code section. That would make sense. I honestly thought it was to objectify data, to be honest. It's objectify data, right? So DRY stands for don't shave yaks. Love it. Don't repeat yourself. Do repeat yourself. Love it. Love it. Dry code is not to make your code shorter and easier to read. It is to make your code shorter and easier, make your code faster. It does make your code easier to do this. So I feel like it actually kind of would make your code faster if you're not repeating it a ton, but I don't know if it actually has any performance stuff. So let's see. We'll go with that one. Nice. Okay, so classes. A class is a special type of value in an object-oriented programming language like Python. Just like a string, integer, or float, a class is essentially a custom type that has special properties. An object is an instance of a class type. In this example, health is an instance of an integer. So integer types is just numbers. So we've just built a variable called health, or what they're calling as an instance of a class type. In object-oriented programming, we create special types called classes. And each instance of a class is an object. So we could put a bunch of these little things in there. Health, height, age, eye color, if this is like something for a hospital or something. So how do I create a class? In Python, you just need to use the class keyword. Easy as that. And you could set custom properties in the following way. It is a custom convention in Python to capitalize the first character in the name of your class. So the class is soldier. If we want to build a class, again, for like a health contract, right? We'd say maybe, what would a patient, right? It would be a patient. I was going to say, what's like a customer of a hospital? That's a bad way to define a hospital. But okay, so anyway, so then create your instance of a soldier. We can simply call the class. Notice that a class isn't a function. It doesn't take input parameters directly. It's not a function like this. You could just stash the parameters within the thing. Okay, so that is cool. So assignment, create a class called wall on line 1. It should have the property called armor. Okay, so let's do that. Armor and is initialized 10 and a height initialized to 5. Okay, let's see. Well, we've already done something wrong. Okay, so let's see. So create a class called wall on line 1. It should have a property called armor. Oh, I see. We were mucking around earlier. And that's what did the mess up. Methods. So classes can also have methods. Methods are just our functions that we've been, right? So all of our functions in Python is a method. Same. And we could put these methods within classes. And these classes only have access to that specific method. Their scope called for this method. So how do I describe this stuff? I say print hello here, or I'll say run fortify function, right? I know it's not spelled right, but ignore that. And then if I built another class, I'll say just wall, right? Or maybe this wall, I don't know. Maybe someone's building a backyard or something. So we'll have a tool shed, and maybe we could have tools. And we could assign that to like an array of strings or something and default it to every tool shed has a hammer, right? This is just an example. And then we can have another function here called open shed. And this would actually be another thing. So I can't actually access the fortify function in this smaller scope down here. So I'll say maybe open shed. But what I could do, I believe, would be tool shed, right? Dot open shed. Let's see if this will work. I'm not totally familiar with the Python syntax. Soldier 1, maybe we have to instantiate it first. So I'll say test guys, boom. Let's see, and then open shed. Let's try that, right? Boom, there it is. Okay, so boom, run fortify function. Here's what actually happened. Open shed happened because we instantiated the tool shed class here. So I'll say tool shed, right, in lowercase. We can name it whatever we want, but something relative to the tool shed. And then boom, we can use the open shed function, but we cannot use, so this is all separate. This is building the thing that we want, the objects that we want, and then this is us using it, right? So let's say, okay, now we want to build the wall. So let's build the wall, right? So we could say wall like this. And we cannot access the open shed function. That's specific to this class, but we can access the fortify function here. So if we do that, boom, we can say run fortify function. So I hope that kind of makes sense. I know it's spelled wrong, but yeah. So we're building these things, and we can append whatever classes we want on them. If we want to do like linked list or binary search trees and build our nodes and all that stuff, we would use classes for some of that stuff. You could use classes for. I'm actually learning a lot about it right now within the EVM, and it's a lot of fun. It is a lot of fun. So I'm going to get back to reading. I just wanted to show you guys a bit of how it kind of looks at a bird's eye glance of building the structure and then using the structures. Okay, so let's see. So method. After that last exercise, you might be wondering why classes are useful. They seem like dictionaries, but worse a bit. Okay, so what makes classes cool is that they allow us to define custom methods within inside of them. A method is a function that is associated with a class, and it has access to all of its properties of the object. So we kind of just covered that, right? So the self value means we can access this. Oh, that's right. Okay, so we could do the self changing. So if we do self, we can change and modify the variable that we're defining within this class. So let's read here. So boom, as you can see in this class declaration, methods always take a special parameter as their first argument called self. The self variable is a reference to the object itself, so by using it, you can read and update the properties of the object. Notice that the methods are called directly on an object using the dot operator. Fun. So we want to double the current armor property. So what we can do is say self.armor times equals 2. And I believe that is all we needed to do. So again, if we had another class just to differentiate that, right? So if we had class toolshed again, right? and maybe we had, I don't know, maybe the height of the tool shed is height 7. We could not access the self.armor because that belongs to the wall class, right? But what we could do is change the height of the tool shed. Maybe it's not 4 to 5. Maybe it's spend weekend working on tool shed. It's a pain in the ass. I know it's a really verbose I know it's a really verbose function name, but it sounds like a pain in the ass to double the height of a tool shed. So yeah, okay, cool. We're learning. So let's submit it. Looks like we've passed it. Awesome. Let's see how much more material we have. Okay, so I might do a halfway point here shortly. We'll run through 1 or 2 more of these, and then I'll do a halfway bit. Okay, so methods can return values. It's normal for a function to return anything. That doesn't return anything, excuse me. It's typically not a very useful function. In contrast, methods often don't return anything explicitly because they may mutate the properties of the object instead. That's exactly what we did in the last assignment. So we changed the wall height or the wall armor. So however, they can return values. Awesome. So this one right here. So boom, it's like returning the speed after we modified a whole bunch. Okay, so add a .getCost method to your wall. What would you expect it to return? So cost is the armor times. Okay, so getCost is going to be self.armor times self.height, right? And then we can return the cost. I think that's all we need to do, right? Cool. So we're taking the armor, right? So we have 10 bits of armor right here times 10 bits of the wall height. Now, the reason why someone might be like, well, why are we doing this? Why wouldn't I just say 10 times 5 right here, right? Like, why wouldn't I just do this? I guess you do have some bit of argument, but until you want to build a new wall, right? So if you want to build a new wall, right, in our program, so we're instantiating the class, this is me using the variable, let's get away from the actual class itself. We can actually pass in things to this if we want into the class. So I'll have this, I don't know how to do it actually in Python, if I could just pass it in like, I'm used to constructors with JavaScript. So basically we would have some sort of constructor that would build the armored walls. So I could pass in the armor and wall, or excuse me, the height, forgive me. And we can initially default them to 10 and 5, but then if we want to build a new wall, right, I can now immediately pass in 25 and 5, right? So now the armor is 25. These are just the default values if no one passes in anything. But now that's why we're using the self.armor for all those things. So we want to just keep dynamic and future-proofing our functions and classes and things like that in mind. And let's try to figure out what constructors are in Python real quick. Does Python have constructors? Let's see. Actually, let's just go to ChatGPT for this one. Does Python have constructors? I'm sure it does. Does the init method? Fun. Okay, so what this will do is fire off when the class is used or that function is first like deployed. So it's a one-time like fires off, sets everything up. So boom, right here. This is perfect. Okay, nice. That's exactly what we're looking for. Cool. So that would be the one-time instance of the function gets fired off and it gets initialized, right? So then we could default values, we could change things, we could pass values in, but that init is going to be very, very important. I'm sure we'll learn about it here shortly. Okay, so methods can return values. Boom, boom, boom. Did we submitted this one? We did. Okay. Which operates within the scope of a class? A method. Which is more explicit in terms of inputs and outputs? I believe a function. Sweet. Okay, so sweet. The very thing. Constructors or initializers. We just learned about it. Let's read about it. So it's quite rare in the real world to see a class that defines properties in the way we've been doing it. It's much more practical to use a constructor in Python. The constructor is defined as this underscore and it's underscore. And it's called when a new object is created. So it's just a one-time function that gets fired off when this thing is created. Just as soon as we call the class wall, let's say we want to use it again, whatever here is going to get fired off as soon as that instance is triggered. So if we need to do things to kind of configure the object, instantiate a few things, initialize a value, default to some values, it's all going to get done. And the constructor runs once. But if we had methods, right, as we just previously had of get cost and things like that, let's say print cost. We could use that method 100 times. We can, if it mutates state and stuff like that, we can use it 50 times or as many times as we need. But with constructors, they're a function that gets fired off only one time, and when the thing gets used, instantiated. So let's read more about it. So with a constructor, the code would look something like this. Let's boom. Legolas has his name, his armor, and number of weapons. However, because the constructor is a method, we can now make the name, starting armor, and number of weapons configurable with some parameters. Fun. Self.boom. Okay, so assignment, add a constructor to the wall class. Here we have our init deal. And it should take depth, height, and width as parameters in that order and set them as properties. So what we're doing here is now going to define them, right? Self.depth and all these other things. These things are all going to be passed into our object, or could be, but this is now instantiating it. So our object has access to these things within the object wherever we want it, or within our object wherever we want it. So now if we want to build, remember how I think two lessons ago, or 2 slides back, right? Lessons are kind of the full thing, but these are like slides, right? But 2 slides back, 2 or 3 of them, we couldn't access a variable if it was specific to a function, or we couldn't access a function if it was specific to a function, right? Doing this gives us global access within this entire class to all of these things. So if I want to build now depth, let's say build wall or something, so some function, I can now access this self.depth wherever it is. So I could say print boom this, but if I also want to use the depth for another thing, right? So depth, build that shed or something, right? I know I spelled it wrong. We can also access it here. So that's what this is doing. It's giving us global access to these variables, and then it's also allowing us to pass in these variables. So we kind of always did have global access to the variables, right? When we did this, when we said depth equals 5, all that stuff, that did work. Width equals 10, right? We still had access to these things, but now we have access to them from being passed into the class. So that's the important bit. So let's run it. Oh, and then it should also compute an additional property called volume, which is going to be self.volume equals depth, right? Times height times width. Sweet. Okay, so in Python, what is the name of the constructor method? Init with double underscores on each side. Sweet. Multiple choice or multiple objects. Let's see how many more we got. Guys, actually, I might wrap it up here, and maybe we'll do a second this episode here. We'll start off on this. This is kind of a heavy-hitting one, right? This will be the start of the next episode. But again, just to circle back on what we learned today, which is the classes are basically, let's say we want to build that class of a car. Let's ignore all of this stuff real quick. So let's say we're hired at a dealership to write some software for a car dealership. Of your classes, you're probably gonna have a class called car. And things within a car, we need to identify these things. So we have make, maybe the Honda, but right now we're hard coding, right? So this isn't what we fully learned. We have a model, right? So maybe like a CRV, right? Maybe you have like year. So like 2008, right? And maybe a color. You have a whole bunch of things, right? A VIN. So maybe 1, 2, 3. I don't know the real VIN number, but we'd have a whole bunch of things, right? A color. I'm roughly describing an old car I used to drive. So beige, boom, right? Now, what we learned was also to use the init function, or the init constructor, where we pass in the self, we pass in all these things that we need, right? So we actually need the make, model, year, VIN, color, etc. And we don't actually want to hard code these things whenever we build a card, because whenever we use this car class, let's say we're using it as an entry to build these things within this car dealership, we would have to re-fire off a new function every time if we built them this way, or a new class. So if I now had a Ford truck or something, right, I would have to say, okay, Ford model F-150, right, so on and so forth, and fill out all the data, which we don't want to do. You don't want to reinstantiate that every time. So that's what we learned about the constructor here, which we can go ahead and make the variables passed in as all these things. So self.make.model, self.year equals year, is assigned to year, right? Self.then is assigned to then, and self.color is assigned to color. Awesome. So now that would be us building a car. Now I want to see actually how to pass in parameters for this car. I want to see this real quick because that I actually don't know how to do in Python. But fundamentally, what we want to do is say instead of what we did previously, where I hard coded all those things, it said Honda, this, that, the other. I would say I could define it as like Honda car, and then I can now call the car instance and then pass in all these things. So I could say a Honda model, what was it, CRV, all those same things, right? 2008, then 1, 2, 3, color, beige. And then we can do the same thing for the Ford truck, right? So Ford truck, right? Now I could easily just build it as simple as this instead of having to build a new class every single time. And the reason is because when you actually start building these things, you don't build them like this. You're likely going to actually get a ridiculous amount of data. So you would actually get all of these things in data, and then you would actually loop through all of those. So the data actually passed in from the car dealership when they hire you as an engineer, it's actually going to be just pools of data, like, pools of it like this, where it's just a ridiculous amount of data. It may not even be this pretty parsed out, right? But when you map through it, this is roughly what you're doing is you're going to map through, oh, then we have another truck, right? Like another car, right? And you're building all these objects. So really what it would come down to is actually just going to be one line of code, right? So you would loop through it all, and then you would have a new car instance here, considering all this data, right? So maybe this is some data. Boom. That would be miserable to deal with, just a list of strings, but maybe they pass it in as a list of dictionaries or something, and you're able to build these car functions this way by looping through that data. So for I in length data dot range of data, right? You could do something like this. So I guess technically, if they did do this proper, you could actually do like data by I suppose, and then data by I modulus equals 1 maybe. Actually, this won't work, but point being is you'd basically loop through a ridiculous amount of data, and then this would build your cars every time instead of hard coding this out. Like we're engineers, we're supposed to be lazy, not ridiculously hardworking. So perfect. So this is actually how to do it, exactly how we were passing it in. Cool. But I hope that makes sense, because when you use it with like 1 bits of data, you're like, oh well, why wouldn't I just like write it out like Honda CRV? But like if you're past 10,000 cars, no, you're not gonna write it out. No. Don't do that. That's a ridiculous amount of work. So the goal is to work smarter here with classes, and this would be kind of the first initial approach. However, you're past the data. You may need to structure the data. You may need a data analyst. Maybe you're past a list of objects, so it makes it clean for you, right? It would be really awesome if all the data came in like this. Then yeah, that would be really fun, because then all the hard work's done for you. But if you're lucky enough to have access to a data analyst, yeah, you would just loop through all the cars here, then construct them, send them to your database or whatever, right? And then the next step would be, send to DB. But that's maybe a little bit more than what we want to talk about. But fundamentally, that's why we're building these classes, right? Is some use case of that, or many use cases, whether it's building, and that's like one data handling use case or somewhat real life use case. There's also like algorithmic use cases. So building like linked lists or binary search trees is definitely one of them, or Merkle roots is another one. But yeah, so I will see you in the next one. Sorry guys, didn't mean to get all crazy on you, but I did want to show like a real world use case of like, oh, why are we learning this? That is why. So I will see you on the next one. Cheers.